This is a demo of the Micromeritics Sub Auto Sizer 2. See, I took off the shield and I'm placing the two brass plugs and two pieces of filter paper on the lower anvil, and I need to select home position. This is a self-calibration that the instrument does to know where the two pistons are, or I'm sorry, the two plugs and the filter paper are, without any sample and without the tube. Just line it up on the bottom anvil. Put the cover back on. There's a magnetic sensor for the cover. If the cover is not on, the system will not allow you to do anything. So you use a touch screen, select home position, and it begins the analysis where it lowers the piston, the upper piston down, and finds where the home position is. This usually needs to be done only once a day. If you do it in the morning, and then you can perform all your work throughout the day, the same home position. This is the first analysis of the day, so I had to perform this analysis. Once it's complete, it says disengaging. You can see on the touch screen. Now you can remove the brass plugs and the filter paper and place it in the tube. There's a special tool called the sample preparation tool. It actually holds the plug and the filter and lines it up perfectly so that it's very easy to press the plug and the filter paper into the tube. So I'll place the plug and I add the filter paper. You can see how it aligns very nicely. Just press. Now we're going to weigh the sample. There's a number of ways you could weigh the sample. You can use a weigh boat. You can place the entire apparatus on the balance and tare. You can use any kind of weighing paper or anything like that, and you just transfer it to the tube afterwards. In this case, I just zeroed the balance with the tube and the holder. And I'm going to add enough sample to get the desired weight. Typically, you want to use the value for the density. So if the density, for example, we discussed that thing by email, if it's 4.6, you want to use, or 4.6 grams per cubic centimeter, you want to use 4.6 grams, because ideally the international standard is you want to have 1 cubic centimeter of volume of material in the tube. That's how the instrument was designed and developed. In this case, with your sample, I actually used more material. So just continue to weigh until you get the appropriate amount. I think I was targeting about 9.24 for the analysis. Now we're back at the instrument when we have the appropriate weight. We remove the shield, and then we place the other upper plug in the holder. We add the filter paper, and then press the apparatus onto the top of the tube. It should click very easily, no struggling. Place it on the instrument, use the guide to lower the guide over the tube, and then you replace the cover. Use a touch screen or a computer to select the appropriate method that was developed. for analysis. You could also add in additional information, such as the sample ID here. I use the number, the lab number that we use to analyze the sample. You could add in any additional information that you'd like regarding like lot number, batch number, things like that. Again, you can use a touchscreen like this. You can connect a mouse directly to the USB port in the on the instrument and use the cursor to navigate, or you can also connect the SAS to a computer using Ethernet and operate it from a browser window. Operating it from a browser window is the same as touchscreen. So here I'm entering the weight of the material now that we weighed. And everything looks okay. You notice that there's a message there that I differ by more than 5%. I found out actually during this demonstration that the instrument will not allow you to continue if you are if your mass is way different from your density. So I had to restart the analysis using the same density and mass, so that they're within 5% of each other. And then later on I can recalculate. So here you can see the analysis is actually being performed. You can see the pressures, everything's red in terms of centimeters of water for the pressure, looking at the flow rates. You see the analysis is being performed. You see data being generated live. You also have the elapsed time, so you can see how long it's taking. Usually it's done within 20 minutes or so. While it's running, we can take a look at the back of the instrument. You can see some additional USB ports, the power supply, the gas line. The gas line is connected to a gas cylinder. The pressure is about 20 psi. This one's connected to nitrogen. You can connect to compressed air or nitrogen. There's a slight difference, but the difference is not going to cause a big error in the values if you're using nitrogen. You'd really want to use compressed air. So the analysis is complete. We remove the tube. And now we just remove the sample and we clean the tube like we normally do. Dispose of the filter paper. You see the plug. This technique obviously is not destructive, so the sample is unaltered in any way. So I just return it back to the stock sample. Again, all we did was just compress it a little bit and apply some nitrogen. You want to use a reasonably high purity nitrogen gas cylinder, or, like I said, compressed air. Compressed air is probably better, since this technique is based on air permeability. All the parameters are set up for air. Air is 70% nitrogen, so that's why there's not an issue with running it using nitrogen tank either. And that's it. Clean up and we take a look at our data.